In this lecture, we'll talk about heat engines. Here, schematic, this is a heat engine. The schematic is the energy flow diagram of a heat engine. The engine itself is represented by this cycle. QH is the amount of heat supplied to the engine by the hot reservoir. The QC is the amount of heat rejected to the cold reservoir by the engine. The branch line to the right, this is the branch line to the right, represents the portion of the heat supplied that the engine converts to mechanical work W. When an engine repeats the same cycle over and over, QH and QC represent the quantities of heat absorbed and rejected by the engine during one cycle. Since it is a cyclic process, then we know delta change in internal energy is equal to 0, right? Then we can say from the first law of thermodynamics, Q must be equal to W, right? Or we can say Q is equal to, our total Q is QH plus QC, magnitude of that, or we can say QH magnitude minus QC magnitude, because QH is entering into the engine and QC is leaving the system or engine, right? So W is equal to magnitude of QH minus magnitude of QC. Okay, so here we can define the thermal efficiency of an engine. So let's say E is the thermal efficiency of an engine, and thermal efficiency is defined as energy we get divided by energy we pay for. So what energy we're getting, the work done, so that's what we are getting, right? And what we are paying for, we are getting this QH. So QH is what we are paying for, that's what. So you supply QH amount of energy, or purchase that much energy, and you're getting that much W joule of useful work, useful energy. Or we can say that is W is equal to QH magnitude minus QC magnitude over QH, right? Or if we keep doing that, then we can say efficiency is equal to 1 minus, because QH over QH is 1 minus QC magnitude of QC over magnitude of QH, right? So this is the simple formula to calculate efficiency of a heat engine, right? One thing we can see here, that if you want the efficiency of heat engine to be 1 or 100%, that means whatever QH you are taking, that is converted into work, and there's no QC. That means QC has to be equal to 0. So QC requirement, QC must be equal to 0 if we want E to be equal to 1 or 100%, right? So we know that QC cannot be equal to 0, because whenever the heat reservoir at temperature TH and cold reservoir at temperature TC, is a cold reservoir, is in contact, they say a spontaneous flow of heat from the heat, this is not heat, this is hot reservoir, hot reservoir. Yeah. So the heat will automatically flow from the hot reservoir to cold reservoir without any effort. So QC can never be equal to 0. So obvious question comes here is that we know that efficiency cannot be 100%, right? However, what is the maximum efficiency we can get? So what is the maximum efficiency one can get, right? So that's a fundamental question, and this question will be answered in our next lecture, um, what we call it Carnot engine. All right.